Number 5 wants us to see which of these conditional sentences are true. Now I've written down the truth table for the conditionals, right? If P, then Q. So all we have to do is identify what is P, what is Q, and then compare their truth values, right? So let's begin with item A, and we'll say, and I'll color code it even. We'll say that P is in blue and Q is in green. So for item A, this is pretty straightforward because it is phrased in a way that says if triangles have 3 sides, then Q, right? So this over here is our P, because if P, then Q. So if P, then Q. So let's see. Triangles have 3 sides. So for item A, we have if triangles have 3 sides. So P is true, right? Because triangles do have 3 sides, and squares do have 4 sides. So we have the combination true and true. And we can see that the combination true exists here in the first row, and therefore the biconditional is also true, right? So in this case, we have true. Let's look at item B. Well, first of all, we have to identify P and Q. And thankfully, this is also if it's stated is in such a way that it's if something, then something. So if P, right, then Q. Okay, now let's look at the truth values of P and Q. Well, hexagons do have 6 sides, right? So P is true. And it's saying that Q, the moon, is made of cheese. Well, that's false. So we have a combination of true for P and false for Q. So this value is represented, this combination is represented in the second row, right? Where you have true and false, for true for P and false for Q. And we can see that the value for the conditional here, it is false. So we're going to say that this one is false. Let's look at item C. So once more, let's identify P and Q. So if 7 plus 6 is equal to 14, right? So this is our P, and our Q is 5 plus 5 is equal to 10. If P, then Q. So let's look at our truth values, right? 7 plus 6 is not equal to 14. It's in fact equal to 13. So P is false. And let's see, Q is 5 plus 5 is equal to 10. That is true. So we, the line, the row that shows us this combination is row 3, where we have P is false and Q is true. And for this one, we can see that the conditional is true as well, right? So this one is true. Let's look at item D now. Let's look at item D, and once more we have to identify P and Q. So if 5 is less than 2, then 10 is less than 7, right? So if P, then Q, where P is 5 is less than 2, and Q is 10 is less than 7. So let's look at these truth values. So P is clearly false because 5 is not less than 2, so false. And Q is also false because 10 is not less than 7. So we go to the row that, the corresponding row for these combinations, which is the last one, where P is false and Q is false. And we can see that for this one, the conditional is true, right? So this one is true. Now let's look at item E. So once more, we have if P, then Q. So if one interior of the right angle is 92, right triangle is 92, then Q, right? If P, then Q. So let's look at whether this is true or false. So P if one interior angle of a right triangle is 92. Well, this is false because a right triangle is a triangle whose angle here is 90. So it must mean that the other two angles add up to 90, right? In order for it to be 180. So it's impossible for an interior angle of a right triangle to be 92. So for E, we have that P is false. And let's see Q. The other interior angle is 88. So it is possible for Q to be true, right? Because it is possible for us to have like an angle of 90 for the right triangle, then 2, and then 88. So while we can say that this one is definitely true. Well, not this is true, but then we can just look at the combinations here, right? Which line does it describe? F is false and Q is true. Well, it is the, let's see, it is the third line, right? Yep, it is the third line. So if P is false and Q is true, then my conditional is also true. Once more, we do have a if P then Q statement for F. So if P then Q. Yeah. So this one is slightly tricky because we don't know whether Euclid's birthday was April 2. Actually, I think that we don't know. Let me see. Euclid's birthday. Let me look this up. I'm not sure that we know this. Yeah, we don't know that with any kind of precision. So we have to consider the possibility where P is either true or false, right? Based on whether Q is true. So for F, I'm going to say that P is unknown. P is unknown. And then we have that Q is true, because rectangles do have 4 sides. True. So let's look at the cases where Q is true. So it is in this line over here and this line over here. And regardless of the truth value of P, right, we can see that for these rows, the first and the third rows of our truth tables, we can see that that P implies Q, is always true, right? It's true over here and it's true over here. So actually the truth value of P does not matter for us over here because we know that it's going to be, the conditional value is going to be true. So we can say that this is true. Now this is a little bit trickier too, item G, because we're saying here, if square root of 2 is not irrational, right? So just be careful, because if the thing that comes after the if is over here, this is our P, and this over here is our Q. So be very careful with your interpretation. So for this one, we have, if square root of 2 is not irrational, then 5 is prime. So let's see. P, so for item G, P, square root of 2 is not irrational. Well, this is false because square root of 2 is irrational. We cannot express it as a ratio of 2 integers. False. And G, let's see, Q, 5 is prime. This is true. So we have false, true. So the line that describes this is line 3, where we have P is false, Q is true, and therefore the conditional is true. And lastly, let's look at H, right? So this one is also a bit difficult to see. Let's imagine that, actually I'll draw it with the proper colors, that this is Q over here, so this is Q, and this over here is P, right? This is what it means for if P then Q, because it means that if I'm in P, I am definitely in Q. So what can we say? Is Q sufficient for P? No, right? Because it could be over here where I'm definitely in Q, but not in P. But I can say that P is sufficient for Q, because if I am in P, right? I am definitely in Q because P is contained within Q. So based on this information, we can say that if P is sufficient for Q, so 1 plus 1 is equal to 2 is sufficient for Q, for 3 to be greater than 6. Now let's evaluate this conditional statement, right? So for H, we have that 1 plus 1 is equal to 2, so P is definitely true. And then Q, 3 is greater than 6 is false. So the row that corresponds to this statement is true, false, so be this row over here. And we can see that for this one, the conditional statement is false. So that is false.